Here we have a sad math question on quadratic function. Okay, let's go with the question. Y equals to x square negative 2x negative 3. A parabola in the xy plane is given by the equation above. Which of the following equivalent forms of the equation displays the coordinates of the vertex of the parabola as constants or coefficients? Usually, the vertex form or standard form of a quadratic function will display the coordinates of the vertex, I mean the x coordinate and y coordinate of the vertex as constants. That is, y equals to a times x negative h the whole square positive k. So this is the standard form or vertex form of a quadratic function. So only in this vertex form of a quadratic function, you'll be able to get the coordinates of the vertex as constants. So here the constant we have at the place of h is the x coordinate, and the constant we have at the place of k is the y coordinate. So this vertex form quadratic function displays the coordinates of the vertex as constants. So now our aim is to write the given quadratic function in vertex form. So among the given options, only in option A and option B, we have a quadratic function in vertex form. So either option A may be correct or option B may be correct. So for that, we have to write the given quadratic function in vertex form. Okay, so let's write the given quadratic function in vertex form. Y equals to x squared negative 2x negative 3. So this is a given quadratic function. Okay, so we can write, actually this quadratic function is in general form. So to convert the general form of the given quadratic function to vertex form, we have to use completing the square method. So to use completing the square method, I need to be aware of the two algebraic identities. That is a square negative 2ab positive b square equals to a negative b the whole square, and a square positive 2ab positive b square equals to a positive b the whole square. Here we have a trinomial on the left side of these two identities, and here these two trinomials are called perfect square trinomials. So because each trinomial can be written as the square of a binomial. So that is a square negative 2ab positive b square can be written as the square of a binomial, that is a negative b the whole square. In the second one, we write this trinomial as a positive b the whole square. Okay, here if 2ab is negative, here we have negative. If 2ab is positive, here we have positive. Okay, so our aim is to write the given quadratic function in vertex form. We need the square of the binomial over here, that is x negative h whole square. So to get the square of the binomial, we need perfect square trinomial over here. So for that, we have to write the expression over here on the left side, either in this form, a square negative 2ab positive b square, or in this form, a square positive 2ab positive b square. Okay, so let me try to write the given expression over here in the form of one of these two trinomials. Okay, let me do it. So I write y equals to x square. So here the first term itself is x square. So here, what is the first term? A square. So clearly, instead of a, we have x over here. So the next term has to be 2ab. 2ab means here we have already 2x. So it has to be written in the form of 2ab, 2 times. So already we have discussed instead of a square, we have x square. That is, instead of a, we have x. So 2ab means instead of a, we have to write x. Instead of b, we have to take some value over here. But the simplification of this stuff has to be equal to the original stuff 2x. So what value should I take? Over here? I have to take 1. So that 2 times x, 2x, 2 times 2x times 1 is, I'm getting 2x. Okay, now I got a square negative 2ab. What is missing? So comparing to this over here, we need b square. Instead of b, what do we have? We have 1. So b square is missing. So we need b square. I'm adding 1 square. So to addition of this 1 square, because simply if I add 1 square, the original stuff will change. So to balance the addition of this 1 square, I subtract 1 square so that it will become 0 pair. The original value will not change. So finally, I'm taking this negative 3 over here. So first, I write this x square as it is, and I'm trying to write this negative 2x as negative 2ab. So in that case, I'm getting 1 for b. So I need b square. So for that, I'm adding 1 square. To balance the addition of this 1 square, I'm subtracting 1 square, and at last I'm taking negative 3. Even if I simplify this expression, it has to be equal to the original stuff. Yes, x square, we have x square over here, x square, and the simplification of this one is negative 2x, and this is 0 pair because positive 1 square, negative 1 square cancelled. We have negative 3, here we have negative 3. So we have y equals to, and now the first 3 terms in this expression, are exactly in the form a square negative 2ab positive b square, a square negative 2ab positive b square. So for a square negative 2ab positive b square, we can write a negative b the whole square, but here instead of a we have x, instead of b we have 1, so we can write x negative 1 whole square for a negative b the whole square. And negative 1 square, the value of negative 1 square is just negative 1 and negative 3. So y equals to x negative 1 the whole square negative 4. So now I got the vertex form, I got the given quality function in vertex form. So here the value at the place of h, that is 1 is the x coordinate and this negative 4 is the y coordinate. So this clearly the quadratic function vertex form over here clearly displays the coordinates of the vertex as constants. So the correct answer choice for this question is option A.